function is something that performs a certain number of steps. I like to think of a function sometimes as a recipe as a function, right? So we have a recipe, right? What are our inputs? Well, that's the flour, the butter, the eggs, any oil, right? Anything that has to go in. The recipe tells us the function, so the steps. Mix the flour and the sugar, add the eggs and the milk, bake at 350. And then we get an output, which is a cake, for example. Okay, so really that function is just telling us what steps to take. It's like a code if you're into computer programming. All right, and so we're starting chapter 4 or unit 4. And this one is called functions. So we're generally looking at functions, transformations, and then we're going to start looking at some specific types of functions. Okay. When I say specifics, well, you've already worked with the linear function. You've worked with the quadratic function, right? Well, we're going to add on to that list of functions. So let's look at the learning goals for today's lesson. Okay. Define a relation and a function. Okay, 2 more words to add to our list of terminology and to understand the difference. Differentiate, so see the difference between a discrete and continuous relation or function. 2 more words, right? We've got relation, function, discrete, continuous. So a lot of new terms, folks. Use the vertical line test to determine whether a relation is a function and understand why that works. Explain the difference between a dependent and independent variable. Write the domain and range of a relation or function, stipulating any restrictions on values. Stipulating means stating or writing down. Explain and use function notation. Okay, so let's look at all those new terms or terms that we must know and understand and know how to use. Relation, function, discrete, continuous, vertical line test, dependent, independent variable, domain and range, and function notation. Okay, this is why I'm really encouraging you to have that list of terminology because there are so many terms. Every lesson has new terms for you to understand and use. So let's first differentiate, understand what a relationship and function is, and then how to differentiate them. So a relation is a set of ordered pairs, okay? Often X's and Y's, but it could also be D and T, distance and time. The ordered pairs are generally listed in terms of 2 variables. The first one is usually the independent variable, right? So X usually is the independent variable and Y usually is the dependent variable. And a relation is called a relation because the value of Y depends on the value of X. Okay, so the Y is dependent on the value of X. So if I give X a value of 0, we will get a specific value of Y. But if I give X a different value, like 2, the value of Y will change. So Y depends on X. Okay. Now, a function is also a relation, but a function is a specific type of relation. So remember we talked about the equation and the function? This is similar. A relation is all of this. A function is a specific type of a relation. So not all relations are functions, but all functions are relations. Okay, and relations could be graphs, they could be equations, they could be ordered sets of ordered pairs, right? Ordered pairs. So an equation is also a type, like is one of the ways that a relation will be shown. Okay, so the specific thing for a function is this. For every x value, there is only one y value. So for every x on the graph, there can only be one dot, right? One value of y. So let's look at these examples. Now, these examples shown in A and B are discrete relations. Discrete is because they are made of individual points. So there is a point, and then there is a break between. This is a discrete function when there is a break between the 2 points. So looking at graph A, the question is graph A a function or a relation? Okay. And so we look at every value of x. So for this relation, there is a value, there's a point right here, and the value of x for this point is 1. What's the y value? Well, it's 5. How about this one? 2, y value 6. This one, 3, y value 7. This point, x is 4, y is 8. So I never said x is 4, y is 8, x is 4, y is 9. So so in this case, yes, this is a function. Sorry, that's not very clear. And we will say since every x value has only one y value. Okay. And one of the things that we will find, one of the mistakes I see students making is that they will say, for every y value, there is only one x value. And that's it sounds the same, but we don't care about the y values. It's the x's that can only have one y. Okay? My little diagram. A relation can be a graph, it can be an equation, or it could be a set of ordered pairs. In this case, it's easiest to write the relation as a set of 4 ordered pairs. Now, when we're talking about a relation or when we're stating a relation, we use curly brackets. This tells us we are listing a relation. And so now I'm not going to write an equation, even though I can see that these 4 dots do create a linear equation. I will list the 4 points. So I've got at x is 1, y is 5. The second point at x is 2, y is 6. At x is 3, y is 7. And at x is 4, y is 8. And then you close the relation with another curly bracket. So between curly brackets is our relation. Okay, and as you can see, we have 4 points. And this is a discrete function because we have points and between them there are breaks. Okay, so the opposite of a discrete function is called a continuous function. Let me show you a continuous function. So this is a continuous function. And what this means, especially when we have arrows, right? So what this function tells us, this relation, is that at every single value of x, there is a value of y. So let's say I chose 2.598. Okay, well, at 2.598, yup, the relation exists there, right? So because it's a straight line with no breaks, that makes it a continuous function, while these points are a discrete function, right? So this is discrete. Let's look at another discrete function. All right. So looking at graph B, okay, is graph B a function or a relation that's not a function? Okay. So function or not function? Okay, so let's take a look at these dots. So again, we've got a set of ordered pairs. Okay, first dot, x is 2, y is 7. Excellent. Second dot, I've got a problem. X is 3, y is 8, and x is 3, y is 9. Ooh. Okay, let's go back to what we said in the first one. We said every x value has only one y value. Look here. This x value of x equals 3 has two values of y. It has 2 points on x equals 3. As such, no, this is not a function. And when we're asked to state a reason, we can say that we could say at x equals 2, at x equals 3, there are 2 y values. Okay, now we're asked to state the relation. So once again, we state the relation within curly brackets. And here we just list the points. 2 and 7, x is 3, y is 8. Again, x is 3, now y is 9. And lastly, x is 4, y is 10. Okay, so another discrete function. As we can see, there are breaks between these points. So in one case, we had a relation that is a function. And in example B, we had a relation that was not a function. Let's talk about the vertical line test. As you may recall from last year, when you're given a graph, you are able to use the vertical line test to determine if a relation is also a function. Okay, so we use this to check, is this relation also a function? How do we do that? If the vertical line goes through only one x value, the relation is also a function. But if the vertical line strikes the graph twice along the same x value, so in a vertical line, the relation is not a function, because in that case there are two x values of there are two values of y for that x value. So let's look. Now before we do, let's define the term continuous that I introduced a little earlier. So these two examples are of continuous relations. And they are continuous because they are made up of an infinite number of connected values, right? You cannot specify how many dots there are, excuse me, in this graph. Okay, so so far we've talked about function versus relation. We've talked about continuous versus discrete. Okay, and now what we're going to do is we're going to use the vertical line test to check if these two relations are also functions. So starting with relation A, I will draw a series of vertical lines and check if any of my vertical lines hits the relation twice. And for relation A, every vertical line only touches the relation once. So what we can say, this is relation C, and this is relation D. We can say that relation C is a function. And in this case, we can just say that it passed the vertical line test. It passed VLT, vertical line test. Let's do a vertical line test for relation B. Ooh, bang. Oh, that hurts. Look, when I drew a vertical line, the vertical line touched the relation twice. And so that means that when x equals 1, y is positive 1 and negative 1. Let me check again, because maybe that was just a fluke. Oh, bang, again. Oh, man. Oh, this is so sad. Yeah. So when x is 3, y is positive 3 and negative 3. As such, what can we say about relation D? That's right, not a function. And for the reason, well, we can say since it failed the VLT. Yes. Side note, you saw me draw this triangle of dots. If you haven't seen that before, that means since. Okay, you probably know this triangle. This means therefore. And the upside down triangle with the 2 dots up top means since. Okay, 2 more terms, domain and range. So the domain represents all the first elements in the relation. And this is usually the x values. So when I am looking at a set of ordered terms, which ones are the first elements? Well, it's the 1, the 2, the 3, the 4, right? It's the first number that comes in an ordered pair. And usually this term is the x term, right? So the domain basically represents all those first terms. The range represents all the second elements, and those are usually the y values. Sometimes restrictions must be placed on these values, but at other times there are no restrictions, which would mean that there are infinite number of values in either domain or the range. So let's practice that. Now, one last thing, I just want to connect the domain and range to the dependent and independent variables. So think back, when I have a function like this, okay, which variable is the dependent and independent? Well, as we remember, when I draw a graph, the independent variable is most of the time the horizontal axis. And that means that x values are the independent ones. These are the variables these are the values that we put into the function machine. And what comes out of the function machine? What is the output? It is the range. Okay, I'm going to change colors here. Wait, I want to write. So independent is the same as your input, same as your domain, where the range represents the dependent values or the values of the dependent variable. And we might speak about these values as the output. Okay, lots of words here. Okay, so let's remind ourselves how it is that we write domain and range. So in this table on the next page, we will be listing the domain and range for each of the first 4 functions we looked at. So the first function was the discrete function, and that was our set of ordered pairs. This one. So as a reminder, the domain is the first elements, the x's, 1, 2, 3, 4. Now note, 3.5 is not part of the domain, nor is 2.7. So when we write the domain of relation A, a discrete function, we list the x values, 1, 2, 3, 4. Did I get that right? I did. Okay, and then the y values are 5, 6, 7, 8. So again, since it's a discrete function, we have just specific points, 5, 6, 7, and 8. Okay, and this describes relation A, which is a function. Now in relation B, again, discrete. So once again, we'll just be listing the concrete or just the discrete values that we have. Let's look back here. So for the input or for the domain, the x values, we have 2, 3, 3, 4. And so since 3 comes up twice, we don't have to list it twice. Okay? And the range, 7, 8, 9, 10. So once again, we are stating just the values 2, 3, and 4. It doesn't matter that the 3 shows up twice. I forgot where we go. 7, 8, 9, 10. All right. And so the range for relation B, 7, 8, 9, 10. Now, as you can guess, for a continuous function, the domain and range look different. And hopefully you remember from last year where we had some special notation for that. So we always use curly brackets. Now, when we're talking about the domain, we start off by saying that for a continuous function, we always state that x belongs to a set of real numbers such that. Okay, so let's just write down what this means. This letter here, might be epsilon, I forget, represents the word belongs to. This big R, sometimes with 2 vertical lines, represents the words a set of real numbers, meaning we're not using imaginary numbers. And this vertical line means such that, right? So you're writing a whole sentence just with some symbols. So let's look at relation C and let's see what type of restriction we have to state. All right. So in this case, so if we're looking just at the domain, what we're trying to look at is at what part of the x-axis does the function not exist? And so if I'm just looking at the x-axis, I can see, wait a second, because of the arrows, it's telling me that the function is going on and on and on towards infinity in the positive direction. And in the negative direction, because of that arrow, again, it goes all the way to negative infinity. So in this case, relation C actually has no restriction on the domain. Every single part of the x-axis has that function on it. And so I actually don't need to state a restriction. So I'm going to erase the such that symbol and just say that the domain, that the entire set of real numbers, so all real numbers, are part of the domain of this relation. That is not true for the range. Let's look at it. Okay, so notice that this function starts at the x-axis and moves upward. So the arrows tell us that this function will go on and on, upward to positive infinity, but it does not go to negative infinity, right? We're looking at the blue line. This function does not exist under the x-axis. So what that means is that that this function only exists where y is greater than and equal to 0. So we state, okay, the range is a set of real numbers such that, and now we say y is greater than and equal to 0. Okay, you could have also written 0 like that. Doesn't matter, right? As long as you get the notation correctly. All right, let's look at the range and domain of relation D. So in this one, which is the one that the entire axis belongs to? Well, we can see for the y-axis, the function will go up until positive infinity and down towards negative. So that means the entire y-axis is part of the range, but for the domain, it's only the positive part of the x-axis. So for the domain, we'll say such that x is equal to, greater than and equal to 0. All right, so in this case, we always start with a set of curly brackets. And because it's continuous, we're saying x belongs to a set of real numbers such that, what was our restriction? Well, the relation only exists where x is equal to and greater than 0. Whereas for the domain, there are no restrictions. Y belongs to the entire set of real numbers. Now, I know this part might be confusing, so maybe take a few minutes to practice some of these homework questions. Maybe ask Ms. Copland some questions if you're stuck on this, and definitely make sure to come to Extra Help to ask about this. All right,